In this video, we're going to go over aromatic hydrocarbons, so what exactly they are, their properties and uses, and rules for naming aromatic compounds. The notes are going to focus on naming, but please know that you will be expected to be able to name as well as draw aromatic compounds here. The reason why these notes focus on naming is because that's the hardest out of the two skills, naming versus drawing. Okay, so with aromatic hydrocarbons, essentially what differentiates aromatic hydrocarbons versus aliphatic hydrocarbons is that aromatic hydrocarbons, they have benzene, okay? Whereas aliphatic hydrocarbons, they do not have benzene in them. So you do need to be aware of the difference between aromatic versus aliphatic. So what exactly is benzene? Well, there's a couple of different ways that we can represent benzene. So you're seeing all the ways here. Okay, so essentially it's a ring with 6 carbons in it, and every other bond is a double bond. That's what it is. Okay, so with this first representation here, okay, we've got these equilibrium arrows just to say that both of these versions of benzene, they're present, they're both present. Okay, so now they look pretty similar. What's the difference? The difference is the locations of the double bond. So here versus here, okay, here versus here, here versus here. So notice that the double bonds are just shifted kind of like 1 over between these two drawings. That is the difference. Okay, and the reason why the double bonds can do this in benzene is just because the electrons are delocalized, or they're sort of spread out among all 6 of these carbons, and that's why both of these versions of benzene are present in equilibrium. Okay, so this is actually something special called resonance structures. Okay, so what they are is it's the same compound, the double bonds are just shifted 1 over. Okay, so you can represent benzene like so, or like so. Okay, all of them get at the same idea. This circle, it just means that it's trying to capture both of these drawings at the same time. Okay, but this can be interchanged with this version or this drawing of a benzene ring. Okay, they just mean the same thing. That's what this is trying to get at. Okay, so some properties of benzene rings, or just benzene in general. So it's going to be nonpolar, and because it's nonpolar, it's not very soluble in water. Okay, so water is polar, and polar is only going to dissolve other polar things, right? Nonpolar substances only dissolve other nonpolar things, right? So if you put nonpolar and polar, they aren't going to be soluble. Okay, now benzene is known to be extremely stable, and it's because of that delocalization of electrons. Okay, benzene at room temperature is going to be a liquid, and some uses of compounds that contain benzene rings is going to be ASA, so acetylsalicylic acid, which is found in aspirin. It can be found in amphetamines. Benzene rings are in adrenaline, so they've given us the IUPAC name of what adrenaline is here, and as well as benzocaine, which is an anesthetic. Okay. Other places where you're going to see compounds that contain benzene is going to be in mothballs, TNT, which just stands for trinitrotoluene, wintergreen, menthol, and SPF in sunscreen. So, when it comes to rules for naming aromatic compounds, okay, there's a key distinguisher here. So we're going to use the name benzene, or we're going to use the word benzene in the name when we have a chain attached to it that's 6 carbons or shorter. Okay, so that's very important to know. We're going to use the word benzene if the chain attached to it is 6 carbons or shorter. Okay, or if you've got multiple branches coming off of the benzene ring, make sure that you give your branches the lowest possible numbers. Okay, now the word phenyl is another name for benzene. However, because of that YL ending, that changes it to be a branch rather than a parent chain. Okay, so that's the key distinguisher between using the word benzene versus phenyl. Okay, so when we're going to use phenyl, which is just treating a benzene ring as a branch, is when the chain attached to the ring is longer than 6 carbons. Okay, or alternatively, when the benzene ring is attached in the middle of the chain, that's when you're going to call it as a branch. So you're going to call it a phenyl ring. Okay. All right. So moving on to some examples here. Okay. So with this first one, we've got multiple branches. So I'm going to treat this as benzene is the parent chain. So let's just kind of write that reasoning over here. Benzene with multiple branches gets treated like a parent chain. Okay, so we want to make sure that the branches are getting the lowest possible number. Okay, so I'm going to start over here, 1, 2, 3, 4, 5, 6, versus we could have started over here, 1, 2, 3, 4, 5, 6. So notice in both cases that doesn't matter which way we number, the branches are either on carbon 1 or carbon 4. Okay, so that means that I'm going to, because it doesn't matter which way we number, we're still using the same numbers, I'm going to give the lower number to the branch that alphabetically comes first. So that's that ethyl branch. Okay, so just as a heads up, how I know this is an ethyl branch, because this carbon and this carbon are in the branch. This carbon right here is not part of the branch, that's part of the benzene ring. Okay, so we're going to go 1 ethyl, 4 methyl, and then parent chain, benzene. Okay, so again, when it doesn't matter which way you count your carbons, right, you still use the same numbers. You make sure that you give the lowest number to the branch that alphabetically comes first. Oh, let's just write that as a note here. How much space do I have here? And it doesn't matter which way you count carbons, you still use the same numbers. Okay, or the branches use the same number. Assign the lowest number to the branch that comes first alphabetically. So it's only in that specific circumstance where it doesn't matter which way you number, your branches still use the same numbers, okay, that you assign the lowest number to the branch that comes first alphabetically. Okay? Otherwise, when you're numbering your carbons, you're just making sure that your branches land on the lowest or use the lowest overall numbers when you're counting carbons. Okay. So looking at this next example, we have a benzene ring in the middle of the chain, and also looking at this chain here. Okay, if we count the carbons, it has 1, 2, 3, 4, 5, 6, 7 carbons in it. Okay, so that's 2 reasons why we should be calling this a phenyl ring and not a benzene ring. Okay. The chain is longer than 6 carbons, and this ring is placed in the middle of that chain, so we got to treat it like a branch. So chain is longer than 6 carbons. And benzene ring is in the middle. Therefore, treat like a branch. So that means we need to use the word phenyl. Okay. So I'm going to number the carbons so that it makes sure that my branches are on the lowest possible number. So I'm going to start from the left, go right. So 1, 2, 3, 4, 5, 6, 7. Okay. So we got to list our branches alphabetically. So this right here is a methyl branch. And this right here is a phenyl branch, so we should talk about the methyl branch first. Okay, so 3 methyl, 4 phenyl. Okay, we're done talking about our branches. Now we need to talk about the parent chain. So the parent chain, it isn't cyclical, so I'm not going to say cyclo whatever. It's just a chain. So I need to say, okay, how many carbons are in this chain? 7. So the prefix that means 7 is hept. There's only single bonds in this chain, so I'm going to end this with ANE. So 3 methyl, 4 phenyl, heptane. 4 phenyl, 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 4 phenyl, heptane. Okay. So I'm just going to get rid of this because I was just using it for the alphabetical point. Now, just as a heads up, students often confuse this with benzene. However, because it lacks the 3 double bonds, it is not benzene. It's just a cycloalkane. Okay, so you gotta watch out for structures like this that are kind of tricky. And remember, benzene has 3 alternating double bonds. Okay, or alternatively it could have the circle. So what I mean by the circle is that circle. So if we were to name this here, let's look at our parent chain. Okay, and let's number our carbons. Okay, so I could number my carbons 1, 2, 3, 4, 5, 6, or to make sure that my branches have the lowest numbers, I could go 1, 2, 3, 4, 5, 6. Okay, so looking here, we got that situation where the same numbers are going to be used whether we do purple numbering or pink numbering. Okay, so I'm going to assign the lowest number to the branch that alphabetically comes first. So in this case, that would be the ethyl branch. Okay, so what that means is I'm going to be going with the purple numbering. So this is going to be 1 ethyl, 3 methyl, and then with the parent chain, that's going to be cyclo because it's a cyclical compound, cyclo, hex because there's 6 carbons in there and there's only single bonds, so cyclohexane. There you go. Okay, so whatever you do, don't get this confused with benzene because it doesn't have those 3 alternating bonds.